Welcome to the GeoPy Beginners Workshop here at the Math2Market User Meeting 2021. I am Janine Hilden and I will show you how to enhance your productivity with customized and automated GeoDict workflows. I studied applied mathematics at the University in Trier, Germany, and since 2018 I've been working as an application engineer at Math2Market. I work on projects, write user guides and tutorials, and I do trainings like this workshop. The goal is that after attending this workshop that you will be able to record and playback macros with GeoDict in order to automate common and repetitive tasks. Also, you will learn how to add variables to macros, to optimize and analyze materials while running parameter studies. Finally, you will see how to access any GeoDict result from a Python macro. In detail, we will start in part 1 with macro recording and parameter studies. There, I will introduce you to GeoDict commands. I will explain to you what are commands and how do they work. Afterwards, we together will record and playback GeoDict commands in form of macros and have a look at the structure of a GeoPy macro. We will introduce variables in the macro and use VaryMacro for a parameter study. Afterwards, we will have the first break for questions and refreshing. In the second part, Python language basics as text output, variables, and string operations will be explained. Furthermore, we will add a second variable and another parameter study. It follows the second break, and we will go on with part 3, where we will record a simulation and access the results from a macro. Also, we will save images from the simulation results. Finally, we will give an outlook on some advanced topics. So let's get started. In GeoDict, almost every action is a command. For example, if you load or save a structure file, run a simulation, or render images or movies, everything is a command and can be saved to a macro. Each command then has a name and a set of parameters. So for example, the result file name or some boundary condition, solid volume percentage, and many more. Therefore, the actions in the user interface execute corresponding commands. These commands then can be recorded in a macro. And this macro consists of a list of commands with their parameters. And if the macro is played back, then the same commands are run again. Additionally, macros can have variables, which can also be set in the user interface. And of course, we want to see these macros and commands. Therefore, as a first example, we create a macro from structure generation. And for this workshop, we will generate a fiber structure. And I will go on performing the steps live in GeoDict. The first thing would be to select a new project folder which fits to this workshop. We have already prepared an empty folder inside the workshop materials folder. So I would recommend to use this folder. Therefore, click on File, choose Project Folder, select Project Folder. So navigate to the Workshop Materials folder. I have saved it to the desktop, for example, and then to the Project folder. Finally, click Select Folder. Now GeoDict saves all following results in this folder. There are two possibilities to save a macro. One way would be to first start macro recording, then execute GeoDict commands that you want to record, and then end macro recording. The second possibility is to first run and then save the commands. Both ways have their advantages, but we choose the second possibility in this workshop, which has the advantage that you don't need to know beforehand what do you want to record. We can simply select the right commands afterwards in the session macro dialog. So now, as we want to create a fiber structure, we have to choose the FiberGeo module. Therefore, we click on Model and then FiberGeo. Now FiberGeo should be displayed in the Modules section in the bottom left of GeoDict. And from the pull-down menu, Create should be selected. Next, to be sure that we have all the same settings for the fiber structure generation, click Edit And then reload the built-in default settings with the third icon here on the bottom left. Now we should have all the same settings. For example, here in the result file name, FiberGeoGDR. Then here we have the domain size with 200 voxels in X direction and also in Y and Z direction. We have a voxel length of 1 micrometer. And here in the bottom right, we have the stopping criterions. So here a solid volume percentage of 10% should be chosen. The solid volume percentage is a geometric measure, meaning that 10% of the volume is solid material, so that the fiber generator will place fibers in the structure till the solid volume percentage of 10% is reached, which also results in 90% porosity. The material for the pore space is air, as we can see here above. Move to the Fiber Options tab, and we see that 2 fiber types are generated. They're both infinite circular fibers and consist of glass. One has a diameter of 10 microns, and the other has a 6 micron diameter. Click OK to close the dialog. Now click Generate. Now the results are shown in the result viewer. We can see that our stopping criterion was reached perfectly. Close the result viewer again. And now the generated fiber structure is shown in 2D view in the visualization area. Let's visualize it in 3D. Therefore, we click here in the toolbar on the 3D button. Then you can turn around the structure by clicking on it and holding the left mouse button. So now we can see it from all sides. To record the generation of a fiber structure, now we click on Macro, and then we select Session Macro. For the current session, GeoDict automatically records all commands from the user interface. They are listed in the upper panel of the Session Macro dialog. In the beginning, we find some commands from starting GeoDict, for example, the GeoDict expert settings and the preferences. And afterwards, we find the commands we executed together, the FiberGeoCreate command, which generated a fiber structure, and then the corresponding result file was opened in the result viewer and closed again. We will need the FiberGeoCreate command. Here, all parameters of generating a fiber structure are saved. If many different fiber structures have been generated in the current session, just double-clicking on the command shows the corresponding parameters. This way you can make sure to save the right command. For example, we can see here that a solid volume percentage of 10% is chosen for the stopping criterion. To save the command, we highlight it here by clicking on it, and then we click Add Selected Commands to File. Then the command will appear here in the bottom panel. Everything in this panel will be saved in a macro when we click Save. So let's click Save. Now we have to choose a name. For example, we can call it Workshop 1, and as we see here, it is saved to the project folder we selected earlier. Before we playback the macro, we close the Session Macro dialog. And then discard the structure, as otherwise we would not see any effects of the macro, as it creates the same fiber structure again. So therefore, we click File and discard structure and fields. Now the visualization area is empty again. So we want to play back the macro to create the fiber structure again. Click on Macro, execute macro script, and now the macro execution control opens. Here on the left, we have the built-in default folders. In the first folder, you can find many helpful GeoPy tutorials and scripting examples, which can help getting started with GeoPy. In the second folder, the Session Macro folder, for every GeoDict session, a macro is saved automatically. This macro contains all commands executed in the corresponding session. For the current session, these commands are also listed in the Session Macro dialog, as we've seen before. And the third folder is the current project folder. We can just unfold it, and here we find the macro Workshop 1 we saved before. So if you highlight it here, on the right we can see all the commands that can be found in the macro. This is a helpful preview panel. In this case, of course, we only see the fiberGeoCreate command, as it was the only recorded command. To play back the macro, we simply click Run here on the right side of the dialog. And then the file fiberGeoGDR already exists in our project folder, as we created it earlier. So we can simply click Overwrite here, as we only repeat the same fiber structure generation. Now we see the same structure is generated again. Next, we want to have a look at the macro. Therefore, go back to the macro execution control, highlight Workshop 1, and click Edit. The macro then is opened in the default text editor, which for me is Notepad++. Now we see here that the macro file starts with a prologue, which has 3 parts. First, there is the header, which contains information about the used GeoDict release, which is of course 2022, the revision, the build date of the revision, the creation time of the macro, who recorded the macro, and on which platform it was created. Afterwards, we have a description. By default, it gives only some information that is also contained in the header, and this description is displayed in the macro execution control. So if we go to the macro execution control, here in the description panel, the same description we find in the macro. But we can change it, of course, to everything we want. Usually it is a good place to describe what the macro does. This way, if you recorded and edited a macro, with a good description, you can give it to your colleagues and they can use it without ever looking into the Python code. For example, you can simply add this macro generates a fiber structure. And if we then click on Save and go back to the macro execution control, we only have to click here Refresh, and then the new description is displayed in the description panel here. Back to the editor, and here after the description we find the third block, the variables section. This section creates a custom user interface accessible in the macro execution control, as we will see soon. By default, it is always a commented out example of the solid volume percentage, and the solid volume percentage is a part of many structure generators in GeoDict. This variables block then consists of a name, which is used inside the macro, the label, which will be seen in the user interface, a type, so for example, it could be double, which would be a floating point number, or an integer, or a string. Even a table or a combo box are possible. After the type follows the unit, which also will be displayed in the user interface, a tooltip, which can be seen when hovering over the label in the user interface, a built-in default value, and a check. So the solid volume percentage is at least 0 and maximum 100, which makes sense when it has to be given in percent. And the last 4 values are optional for most types. And then it follows a commented out explanation of the variable syntax. For example, find here a list of the possible types. And for all variable types, you can also find a description and an example in the automation and scripting user guide, which opens if you click Help in the macro execution control. After the variables description, you'll find some examples of variable usage and some frequently used Python syntax. So comments can also be helpful to make a script more readable. They are always introduced by a hash in Python, so everything which comes after this hash is ignored when executing the macro. The macro is always executed from top to bottom, and now here starts the block with the recorded commands. Our workshop macro only contains the command to create a fiber structure. The prologue before is always a part of a recorded macro in GeoDict, even if no commands were recorded at all. But here we have one command in the command section. For each GeoDict command, the parameters are saved in a Python dictionary, which is assigned to a variable, in this case create args1, and a dictionary always consists of key value pairs. We see the keys on the left and the values on the right. These keys correspond to the respective parameters in the FiberGeo options dialog, as for example the number of voxels here in X, Y, and Z direction, which define the domain size, and the solid volume percentage, and the result file name. In Notepad++, you can collapse the sections by clicking the minus sign here. You can also collapse the whole domain or the whole command dictionary, and this can give a good overview as many commands are recorded so you can see more commands at once. In the first line after the dictionary now follows the actual command, the gd.runCMD, which stands for run command. This command needs 3 input parameters. First, the name of the command, here the FiberGeo create command, then the parameters dictionary, which is defined above, and then the GeoDict release. This third parameter could also just be 2022 as a string, but in recorded commands, the release is always read from the header, as values of Python dictionaries can be accessed by entering the corresponding key here in square brackets after the dictionary name. So we can compare this with the header dictionary above. So scroll up, right here at the top, and here we find the header dictionary. And here the first key is the release, and this release has the value 2022, and this then is the input for the gd1 command. So we now have a macro that always generates the same structure. This is not very useful. What if we want to vary some aspect of the geometry generation and generate several variants automatically? We need to vary some parameter of the structure. Therefore, we can use a parametric macro and vary the parameters from the user interface. Variables in the variables block in a GeoPy macro then can be assigned a value by the user directly from the user interface. This allows to write a parametric macro and provide it to colleagues who can use it without ever touching the Python code. We save a copy of the Python file, so we don't lose the original. Therefore, we click on File, Save As, and change it to workshop2.py, and make sure that it is saved to your project folder again. And if you don't use Notepad++, it can be necessary to select the right file type, which would be python.py. But in Notepad++, the file will be assigned to the type corresponding to the entered ending automatically. In some other editors, it could happen that this would result, for example, in workshop2.py.txt, which of course will not be recognized as a Python file anymore. So then click Save. And now in the variables section, we change the number of variables from 0 to 1. Then we uncomment all the green lines by removing the hashes. And now the variable for solid volume percentage will be accessible in the macro execution control, but has no impact yet. Therefore, we have to remember the name we gave to the variable, GDSVP. And this name, by the way, can be chosen as desired. You only in the macro need to use the same name as you chose in the variables section. For readability of the macro, however, it is recommended to use a name that describes the variable's usage. So SVP is a recognizable short form of solid volume percentage. And the GD prefix we also only use for readability, as this way we can recognize which variable was set from the user interface and which is introduced within the macro. Back to giving the variable some impact. Therefore, scroll down to the create args1 dictionary, and there in the parameters we look for the line with the key solid volume percentage. There, we replace the number 10 by the variable name, which is GD_SVP. And then we click on Save. This way, we use a floating point variable with the name GD_SVP in the parameters for Fiber GeoCreate, allowing us to change this value from the macro execution control. Now go back to the GeoDict user interface, and here above of the visualization area, we click on the Statistics tab, and then unfold the pull-down menu. And then here we can see the volume percentage for all the materials. And for glass, 10% is given, which was the value for the key solid volume percentage in the macro. But we will change that now. We open the macro execution control again, either from the taskbar or by clicking macro execute macro script. I did not close it in between, so I have to click refresh to make workshop 2 appear. As you can see, while workshop 1 is still highlighted, the parameters button on the right here is grayed out. But as soon as we highlight workshop 2, this button becomes available as we introduced a variable. It allows you to define a value and run the macro using the given value. Click Parameters and a new dialog box appears. Here we see the label, solid volume percentage, the unit, percent, and the built-in default value, 10, that we defined in the variable section. Also, when we hover the mouse over the label, we can see the tooltip. To create a denser fiber structure, we just changed the solid volume percentage to 25. This value then will be used for the variable GD_SVP. So now we click OK, and then Run to execute the macro. Now a new structure is generated, so change the name by adding 25 and clicking Rename to save the new structure under a new name. It is possible to automate this renaming task, but we will come to that later. Now we can see that a much denser structure is generated. We can also verify the solid volume percentage value again by looking here to the Statistics tab. Our first structure had 10% solid volume percentage, and the new one now has 25%. In the second part, we will add a flow simulation step after the structure generation. And as the simulations themselves are not so important in this workshop, we can generate smaller structures to decrease simulation time. Therefore, modify workshop 2, and in the Create Ax1 dictionary, we search for the domain parameters nx, ny, and nz, because these determine the number of voxels the domain has in x, y, and z direction. Then we replace the value 200 by 100 for nx, then also for ny, and for nz, and save the workshop 2 by clicking Save. This, of course, is not representative cutout anymore, but to decrease the simulation time in this workshop, it is reasonable, as we are more interested in how to automate than in the results itself. The next step would be a parameter study. Now we can see the benefits of adding a parameter to the macro earlier. We can vary its value automatically. Back to the macro execution control again. Then here above of the command preview, select Vary instead of Fixed. And if we then click on Parameters, we can enter a value list instead of only one value. For example, enter 10, 40, 70 for the solid volume percentage. The values must be separated by commas. The macro then will be executed 3 times, once for each value. For multiple variables, you can have the given values vary in parallel, or even run all combinations, which would be the cross product. We will see that in the second part when we add a second variable. So for now, we click OK and Run. And now we have to change the result file name manually but as promised already, we will automate that soon. So here at 10 for the first one. Then the second one would be 40. And the last one would be 70. So back to the GeoDict visualization area. Here we can see the last generated structure with 70 solid volume percentage. This is where we dance. Again, we can validate the solid volume percentage in the statistics tab here. And if you want to see the results from the whole parameter study, we can open the project folder by clicking File, choose Project Folder, and Open Project Folder. Now the project folder is opened, and here we can find all the result files and result folders, and of course the two macros we generated in this first part of the workshop. For example, the first fiber GeoResult that we only used for recording the macro, and then the 25, our first edited variable, and then the 3 result files from our little parameter study here, 10, 40, 70. As always in GeoDict, the results consist of a result file containing some information about the simulation and a result folder, in this case only containing the generated fiber structure. Here in the slides we can also see an overview of the 3 generated structures as 2D slices. Here all the fibers got the same color to only focus on the overall density, which of course becomes higher with increasing solid volume percentage. This is the end of part 1. Now we've seen how to record macros and insert variables to them for parameter studies. So it's time for the first break, which gives us time for questions.